Welcome, dear students. I, Dr. Neelam Yadav, Assistant Professor at ABES Engineering College. I'm presenting this lecture video on engineering chemistry. The topic of this lecture video is liquid crystals. The topics or the contents which will be covered under this lecture video are introduction to the liquid crystal, definition of liquid crystals, classification of liquid crystals, which are being classified as thermotropic liquid crystals and lyotropic liquid crystals, and the applications of liquid crystals. Starting with the introduction of liquid crystal was first studied by an Austrian botanist named Friedrich Grenzer in 1888 while working on a substance named as cholesterol benzoate. He found that when the cholesterol benzoate was heated, initially it turned into a hazy liquid, and further increasing the temperature changed it into a clear liquid. That means this cholesterol benzoate was showing two distinct melting points. It is here that it was found that there exists some kind of a phase which is called as liquid crystal. Now further, when we were studying about the liquid crystals, it was found that these substances generally exhibit a long range order, and that long range order is only found either in one or two dimensions. This long range order is never found in all the three dimensions simultaneously. So we can say that liquid crystals are the substances which are having long range order in any one or two dimensions, but not always they are having three dimensions order. Now, when we define a liquid crystal, it is defined as a state of matter. It is a state of matter that is intermediate between solid crystalline form and the ordinary liquid phase. As we all know, the structure of the solid crystalline form and the ordinary liquid phase, and it is also shown in this figure. Solid crystalline phase is having the structure where the molecules are having a fixed position and the long axis is also oriented in one particular direction. While when we are talking about liquids, the long axis of the molecules are not always oriented in one phase, and also the position of the molecules is not also fixed. Now, the intermediate state between this solid and liquid, which was observed while studying the cholesterol benzoate, this is called as liquid crystal. When we are talking about liquid crystals, then we are majorly concerned about the positional order of the molecules and the orientational order. Now, when we are generating a liquid crystal, generally this can be done in two ways. Either the solid is heated, and at a particular temperature, when we are heating at a particular temperature, this solid may turn to a liquid crystal, and on further heating, it will turn to a liquid. Similarly, if we are taking initial substance in the form of a liquid, this can be converted into liquid crystal by cooling it down, and on further cooling, this liquid crystal will convert into a solid form. So basically, we can define a liquid crystal as a state of matter, which is an intermediate between solid crystalline and ordinary liquid phase, and it will be showing the properties of both solid and a liquid phase. Okay. Now, when we are talking about liquid crystals, this liquid crystal can be generated, this can be formed by using a solid material, and this solid material can be converted into thermotropic liquid crystal while we are increasing the temperature. And this crystalline state can also be converted into another form of liquid crystal, that is lyotropic liquid crystal, and this is done by addition of solvents. This will be I will be discussing further in this topic. There are some important characteristics of liquid crystals which is being used to define a liquid crystal. The liquid crystal structure can be described by the following parameters. The two major parameters which is being followed to describe the liquid crystal are orientational order and positional order. When we are talking about the orientational order, this suggests that if a molecule is in this form and this is the long axis of the molecule, then maximum molecules in a plane are having a direction in one particular direction, or majorly placed in one particular direction, or they can have any of the direction, and this direction is defined as the orientational order. Similarly, another point which tells about the liquid crystal is its positional order. These molecules, although like in the state of solid phase, these molecules are not having a fixed position. They are slightly moving. So the positional order is also dependent upon the average of the molecules, average number of molecules that are having the position, that is defined as the positional order of that liquid crystal. So basically, when we are discussing about liquid crystal, we will be discussing about its orientation, the molecules. We will be discussing the orientational order of the molecules on an average, and also the positional order of the molecules on an average basis. Now, classification of liquid crystal includes, basically, liquid crystals are being classified into two forms: thermotropic liquid crystal and lyotropic liquid crystal. Further, the description of thermotropic liquid crystal is given as nematic liquid crystal, smectic liquid crystal, and cholesteric liquid crystals. Discussing about the thermotropic liquid crystals, basically, thermotropic liquid crystals are the liquid crystals that become a liquid crystal at a certain temperature range. It's not necessary that if a substance is given, it will behave as a liquid crystal. It can also behave as a solid, and it can also behave as a liquid. While taking an example, if a cholesterol benzoate is being heated, it shows the characteristic of a liquid crystal at a temperature range of this 145.5 degrees centigrade to 178.5 degrees centigrade. Below this, it will be showing a solid phase, and above this temperature, above 178.5 degrees centigrade temperature, this cholesterol benzoate will be showing the liquid phase. Further, another example of thermotropic liquid crystal can be taken as para-isoxyanisole, and the temperature range at which this para-isoxyanisole shows the liquid crystal phase, it is the range of 116 degrees centigrade to 135 degree centigrade. So basically, what we understand over here is that thermotropic liquid crystals are those substances which behave as a liquid crystal when their temperature is increased and the temperature reaches a particular temperature range where this will behave as a liquid crystal. Further, these thermotropic liquid crystals are divided into three types: nematic liquid crystal, cholesteric liquid crystal, and smectic liquid crystal. I'll be discussing these liquid crystals in further slides. Now, what is nematic liquid crystal? Generally, nematic liquid crystals are also termed as thread-like liquid crystals because the structure of the molecules in this nematic liquid crystals are elongated and rod-shaped, and so it is also called as thread-like liquid crystals. The major properties or major parameters of this nematic liquid crystal includes that they have no positional order. As in the figure, we can see that if this is the plane of molecules, this is the plane where the molecules are existing. In this plane, the molecules are not having a particular position. It's not defined that all the molecules are arranged in a particular position. Although they have some orientational order, we can say maximum or average number of molecules are oriented in a particular direction. So basically, nematic liquid crystals are those liquid crystals in which the molecules on an average are not having or not possessing positional order, but they are possessing some orientational order. This nematic liquid crystal has one of the major properties that it doesn't shows any optical activity, or we may say it is optically inactive, or it is a racemic function. Next thermotropic liquid crystal is cholesteric liquid crystal. It is also called as chiral nematic liquid crystals. The name chiral nematic liquid crystal is given to this cholesteric liquid crystal because most of the or maximum properties shown by this cholesteric liquid crystal is similar to that of nematic liquid crystal. That is, they are not having positional order, but they are having some amount of orientational. The major, and now why it is called as cholesteric liquid crystal? Because major examples or maximum molecules which show cholesteric liquid crystals are derivatives of cholesterol. Another name given to this chiral nematic liquid crystal is twisted nematic liquid crystal. Now, this twisted nematic liquid crystal is given name. This name is given to this substance or this liquid crystal because of the structure which it follows throughout the on different planes. Now, one of the major concern about this cholesteric liquid crystal is chiral liquid crystal is major point is that this is exhibited by the molecules which possess chiral centers. Okay, now the substance which is made up, they will be having chiral centers and they will be showing the cholesteric liquid crystal property. Now again, when we see this structure of the cholesteric liquid crystal, over here we have written a word director. Director is the direction in which the maximum molecules, the long axis of maximum number of molecules in a plane, in a particular plane, the direction of maximum number of molecules is shown, and this direction is called as the director. That means the average direction of the long axis of all molecules in a liquid crystal is termed as director. Now, one thing more which is included in this cholesteric liquid crystal is the term pitch is included in this. What is pitch? The pitch is when the direction of the long axis direction of the molecules gets rotated to 360 degree. Like in this plane, the direction of maximum number of molecules is towards the right, and as we move towards forward towards any of the planes, the pitch is defined as the condition where these directions get converted into 360 degree. Now, when the total rotation is converted to 360 degree, this distance is called as pitch. So if the plane is directed towards the right, now the subsequent planes will show different directions, and when we reach to a plane where the direction is again towards the right, that distance between this is called as the pitch. Basically, pitch is temperature dependent. As the temperature is varied, the pitch gets changed. For nematic liquid crystal, the value of pitch is always infinite. Third form of thermotropic liquid crystal is smectic liquid crystal. There are many varieties or many variations of smectic phases are available. Here we are discussing two phases. One is smectic A and the other one is smectic C. The two major or two important phases which we are discussing about smectic A and smectic A and smectic C. Smectic A are those. Okay. Now in smectic liquid crystals, they are having positional order as well as they are having some orientational order. Now in smectic A, the maximum number of molecules are oriented parallel to the director, and the direction of the director is always perpendicular to the plane of the molecules. This is the plane of the molecules, and the director is perpendicular to this. And similarly, the long axis of the molecules is also perpendicular to the plane, and maximum number of molecules are having their direction parallel to the director. However, in smectic C, although the molecules are similarly having the positional and orientational order, but the maximum number of molecules having their long axis which is tilted at a particular angle. So this is what is included in smectic C. Now next is lyotropic liquid crystal. It is another form of liquid crystals, which is lyotropic liquid crystal. Generally, lyotropic liquid crystals are having amphiphilic molecules. Amphiphilic molecules are those molecules which are having two parts. One part is called as hydrophilic part and the other part is called as hydrophobic. When these molecules, amphiphilic molecules, are dissolved in a solvent, in appropriate solvent, in that case, the polar head or the hydrophilic part gets attached to the solvent, and the non-polar part or the hydrophobic part or the solvent repelling part, it is directed away from the solvent. To make a lyotropic liquid crystals, particular concentration of an appropriate solvent is used, and the substance is mixed in the solvent at a particular temperature and pressure. The resulting substance is a lyotropic liquid crystals. So basically, in lyotropic liquid crystals, the concentration of solvent is an important part which decides whether the following substance will get converted into lyotropic liquid crystals. That will completely depend upon the concentration of the solvent. Example of lyotropic liquid crystal is biological membranes. Now, these lyotropic liquid crystals can further be divided into cubic lyotropic liquid crystals, hexagonal lyotropic liquid crystals, and lamellar lyotropic crystals. In cubic lyotropic liquid crystals, generally what happens is all the molecules of lyotropic substance convert themselves into a Mitchell, and this Mitchells